Hey guys, as I mentioned in the previous video, today I'll be showing you how to set up Python virtual environments on your Mac or Linux computer. So a virtual environment is essentially a way that you can use different groups of packages that you've installed and refer to them by name. So one of the most popular ones of managing this, a package manager would be Anaconda or Mini Conda. And I think it's a lot nicer, it's reproducible way to maintain your code. So for example, I have all my machine learning installables in one Conda environment. That way, if I ever want to do something that involves the most often machine learning things that I do, I just activate that environment. Whereas if I want to do web development stuff, I'll have a different environment. And it kind of keeps things, I guess, well maintained. So now if I want to share my machine learning stuff with someone, I can just share the environment that I have for that, and they don't need to get all the other packages that I have installed in my other environments. It also allows you to have different versions of stuff installed for different reasons. So for example, you might want to run a particular bioinformatics workflow that requires certain packages to be installed, and you don't want to mess up with the ones that you currently have on your computer. So you can just install those into their own little environment. Anyways, they're really useful. If you're interested in more, feel free to go to one of these websites. There's tons on Google, and they're really useful. So firstly, I'll show you how to download it. So I prefer to use Mini Conda because it doesn't come with a lot of things pre-installed. So Anaconda is the full version, and it has like scikit-learn, I think, or SciPy installed, and just a bunch of other programs. But I prefer Mini Conda. It's up to you. But I'll show the Mini Conda download. It's also quicker. So the installer, I'll just click on my Mac OS 64-bit one. So you just download that and it'll go probably to your default download location. So we'll just move over to the terminal then and CD into our downloads. Now what we want to do is, before we actually run it, see this SHA-252 hash thing? So a hash basically allows you to check that you've got the right package and that hasn't been messed with. None of the code has been, corrupted or messed with by a hacker or something. So I always recommend checking the hash. The hash will be different even if one bit in the data changes, so it's pretty secure. And the way that you can check the hash is just by writing, I think it's SHA-256, let me double check. I've written it before. History type grep SHA. So SHA sum -a. This is actually 252. Mini Conda. What? Let's see if it's 256. Cool. Don't know why they got 252. That must be a typo there. 256 is the most common one. Anyways, the SHA is correct if you type SHA-SUM -a 256 Mini Conda and the version that you downloaded. So then you just want to run that the normal way that you run it. Alternatively, you could have also downloaded the package and checked that as well. I've already got it installed, so I don't need to do that. So come back when you've installed Mini Conda on your computer. Okay, I'm guessing you've come back. So what we're going to do is we're going to set up a new Conda environment using either Mini Conda or Anaconda, whichever one you decided to install in the previous step. So the first one you're going to need to do is the conda create. And so you just type conda create -- name, and then what we can call this is anything. Let's call it video env, and give it a version of Python. So we're going to give it Python 3.8. But you could do 3.9, 3.6, 2.7, anything. So what Anaconda is basically doing, it's now creating a new folder with the default package information in a location on your computer that you can then use. So we're just going to proceed because it's just saying to download the default things into it that it needs to be able to run. And we'll just wait a couple of minutes. Oops. Can probably close this now. I'll make this a bit bigger. So if you notice down here, it says to activate this environment, use conda activate video env, and then to activate, you use conda deactivate. Now, how do you know that what environment you're in? It's actually really useful. For me, it shows up here, and for most people it will as well. Otherwise, you can just type which Python. So the default for me, because I've installed miniconda, is my miniconda 3 bin/python. And so Python will always, this is basically just the executable. So basically a symbolic link to writing that Python command. I think it's, so I could also, instead of writing that, I could write this entire path and it'd give me the same thing. And to exit from Python, you click Control-D. So to activate the environment, we're going to go conda activate video env, or whatever you called your environment. Now we can see that this base has changed to video env. We can now deactivate that, and it'll be activate video env, and it'll go back to the base environment. Whoop. Oops, I don't actually need to even type anything in. Activate. Spelling is important in coding, and I always forget about it. Cool, I don't actually usually bother often to deactivate my environments, because when you exit the terminal, it'll deactivate by default. So let's go back into it. Also, you can do this from anywhere on your computer and it won't make a difference. So I'm doing it from my downloads folder, but you could be in your documents or your base one. So what we're going to do is we're going to activate the environment, and what we're going to do is install a couple of packages. So currently we don't have much installed, so we've just got the default packages, and you can see what's installed by typing pip freeze, which usually doesn't take this long. Odd. I wonder why that is taking so long. Yeah, so there's nothing actually installed. I don't know why that took so long, but normally it doesn't. My computer must be having a little meltdown. So we're going to go now pip install numpy and just install a default package. So this might take a little bit of time to download, depending how quick your internet is. So now we can just type pip freeze again. This time I'll just let it go out. Cool, it's quicker now. I think that was just the first time the environment had run. So we can see that we have the previous one, and now we've also got numpy, and it tells you the version at the end. So let's go pip install. You can also install multiple things at once. So Seaborn and Pandas, for example, and that'll install both of them. And then the most common way is actually to install via a requirements file. So that pip install -r requirements.txt. So say we want to save our environment so that someone else can install it, we just go pip freeze, and usually we use that redirect command that we learned in the previous video. Redirect requirements.txt. And now if we go into our requirements.txt, someone can install the exact same environment, so they can make basically make sure that our code is running exactly as it should, because it's got all the same defaults, well, all the same packages installed, the exact same versions too. So it's really useful. Cool, and up next, we have setting up an integrated development environment, which is just a nice way to be able to program things, because sometimes using Vim gets a bit tedious, and a good IDE makes coding a lot easier. So I'll see you then.